have a neurosurgeon, a pathologist, and an epidemiologist. They had to enter a room, an empty room, one by one, which has just a surgical table, and on the surgical table there's a can of sardine. So the neurosurgeon entered for 2 minutes. After 2 minutes, he went out with a report and couple words. He said that there was a surgical table and there was a can of sardine. So the pathologist entered for half an hour. She or he came out full of oil, and he wrote a 2 pages report about that I opened the can in that specific way, and it has 6 sardines in it, and nothing pathologist was there, and I think it was a flower oil. The epidemiologist entered for 8 hours. Everyone was exhausted. That he went for 8 hours, so everyone was wondering what is he doing there. He came out exhausted, and he wrote a 20 pages report about ways to know what is in the can without opening it. Oh. So he was just studying how shall I know what is there and I can't touch it. So that was a joke actually, it was an experiment. So that's how epidemiologists work. He works with hypothesis, he works with numbers, he works with words. So he doesn't really work. I don't know if that's the real work of epidemiologists or not. Okay. So today we're going to talk about epidemiologist role, classification of disease, incidence and prevalence, source of data, cohort and case control, study design, susceptibility and immunity, and the transmission of viruses. So it's just basic lines for epidemiology. We're going to start with epidemiologist role. That's the epidemiologist, which works, its work is to research the causes and consequences of diseases. He collects and analyzes the data, he reports the findings he found, and he helps prevent spreading the disease. He actually helped in the public health policies, and he helped in disease management strategies around the world. So he's a very important one. Actually, in the medical or in the world, he is a medical detective. That's what is the epidemiologist. We're going to talk about classification of disease. The disease is classified into 3 categories: sporadic, which is an intermittent disease. It's not regular, irregular, and endemic, which is regular, it's a chronic, and hyperendemic, which is where there's high levels of disease, so it's hyperendemic. Endemic is subtyped into common source. That's the disease that comes from water, from food, so it's common sources for people. And there's the propagated, which transmits from one person to one person, so it develops. And there's the mixed, which can be common, then be propagated. Incidence and the prevalence. They are very important in epidemiology. Incidence is a measure of disease that measures the probability of having a disease during a period of time. So I'm gonna study a group of people and see what is the probability of each one to have this disease during a period of time. So period of time is very important to distinguish between incidence and the prevalence. Okay? So we'll have an example. 200 women, study a group group study was 200 women. We followed up for a year, and after a year, there was 5 women who developed breast cancer. So we say that the incidence of this category or of this study group to develop a breast cancer is 5 divided on 20, and that's 0.025, which means 2,500 person per 1,100 women in a year, in the years of study. Okay. The other one was prevalence, which is also a measure of disease, but it doesn't measure probability. It actually measures likelihood to have a disease, and it's not about time at all. So we just take a group of people and we don't follow them. We just study them as they are. So we're going to talk 40,000 women, and we saw that there was 1,200 who recently had breast cancer, and 3,500 who are actually living with breast cancer. So we say that the prevalence of breast cancer in this study group is 1,200, which are the recently, and 3,500, which are the living women with living with breast cancer, divided on 40,000. So it's 0.118. That means 750 per 100,000 persons. Do you notice that we didn't use time at all? So that's a big difference between incidence and prevalence. We're going to have a little bit harder exercise. There's no pen? So I'm going to take this study group, which is 40,000 women. We said that 1,020 recently had breast cancer, and 3,500 that are actually living with breast cancer. So both of them are actually infected, right? So we said that prevalence is 1,200 plus 3,500 divided on 40,000. So if we study those or follow up for a year, okay? So we followed up them over a year. So after this year, let's say 200 more than those developed breast cancer. So who can say to me, clear, what is the prevalence?
You can't say prevalence because you say the year.
Yeah, okay. After a year, I returned to take those 40,000 and study them for the time. So that's right. There's no connection between time, but I'm saying that after a year, I just take them new.
They developed breast cancer and they're living with, or is it just developed without any symptoms?
What do I care about is that they have breast cancer.
So what is 3,500?
Yeah, they said there's no. They said that because there's no difference between if they recently got it or living with it, unless unlike the evidence, the incidence. We said in incidence we took the one who developed, so who recently have breast cancer. Okay, this exercise will make it clear. Okay, so here we say that the prevalence, what we said there is 3,000 women, right? So I know previously that I have 1,200 infected and 3,500 infected. They are the same. They are both infected. So recently I had 200 more. So now I have 200. So when I study this group at this time, okay, let's say from a year I had this study. So now I'm here, okay? I have this 40,000 people. I have, actually, we're gonna sum them because we don't wanna know. Okay. So I have 4,700 who are infected and 200 who are also infected, right? So actually, how many people are infected?
4,900.
Right. So I have 4,900 people who are infected, right? So can I say what is the prevalence?
Yes.
Okay, what is it?
4,900 over 14,000.
Yeah, that's right. That's totally right. That's the prevalence, okay? So let's talk about incidence. Do you remember incidence?
Recently, so 2,000. We have the 200 people having cancer recently, so 2,000 people, 200 people.
Yeah, that's right. So I just take the recently. I take the one I followed up them. So what was there I don't really care about. I care for who developed during this year. So that's the incidence. Okay. So the incidence here is 200 divided on 40,000. Is it clear? So incidence is about time, is about follow-up, and I care for just the ones who I'm studying and they developed. They didn't have this disease and they developed it. And in the prevalence, I don't care for time. I just take the speechment, I can say, the population, and I study them in the right, in the real time. Any questions about this? Is it clear?
Yeah.
So, since we know incidence, so we're going to know what are the parameters that affect the incidence. Who can say to me?
Time.
Time, not really. So, the proportion of susceptible, how much susceptible people can be, and the proportion of infectious people, and the rate of contact between the susceptible and infectious. Because when there is contact, the disease can develop more, and case, infection, and fatality. We didn't speak about fatality. If this population, which was 40,000, okay, after a year, let's say 10 of them died, what's going to happen for the prevalence?
Must be changed to
reduced.
add this in the
So is it going to decrease or increase?
Ratio increase.
it's gonna be increasing.
Is it going to increase the prevalence?
Yes.
Prevalence is number of infected people on the number of the whole population, right? So those 10 died from cancer. So they died from here or from here? From the infected?
From the
Infected from the old.
Affected.
Yeah, they died from the infected and they died from the old. So it's going to decrease. It's going to decrease. Prevalence is going to decrease. And the incidence won't really have a relationship. Okay. So, two things decrease the prevalence. Died and
Recovered.
That's right.
Recovery.
That's right. Recovery. So recovered people and dead people will decrease the prevalence for me.
Recovered and died
Yeah.
are gonna decrease it.
Yeah. the reports. So any reports, any official reports, you will take it and collect the data from it. Okay. Cohort and case control study. Do you remember them from today? Okay, we're not going to talk about them, but actually we did. Okay. Susceptibility and immunity. We classify society into three things associated to diseases. Susceptible, one who is susceptible to have a disease, who is anyone healthy, and one who is infected or infectious, and the one who is immune. But in the case of persistent virus infections, which happens with viruses like HIV or HSV, we actually divide the society into two things. Suggest we have now susceptible and immuno, but infectious. So actually, we don't have someone who's infectious because it's chronic. There's no acute symptoms. So we say that he is immuno, maybe, but infectious. Okay. Finally, transmission viruses. Viruses can either maintain in single species, so just human, just dogs, just birds, etc., or infect different host species. That's classification. Actually, we need numbers for this. Epidemiologists don't speak about words; he speaks about numbers. So the number, let's say, the numerical value that speaks about transmission of viruses is named reproductive rate. Reproductive rate is number of new infections by a single individual. So I have a single individual who infected people. Okay, so I'm gonna calculate the number of those who are infected from single one. Okay, divided on the susceptible population over an individual's infectious period. So it's all about an individual. I have an individual who are infected. Okay, so I'm gonna calculate the number of people who are infected from this one, and I'm gonna calculate the population during his infection. Okay, so it's all related to his infection. Is it clear? Yeah. It's actually a ratio. There is no rational explaining for it.
No, I'm not. I'm just reading susceptible population over an individual infectious period. So not all the population, just are the susceptible.
Yeah, susceptible they are the ones who are healthy, who are not infected, but they can be infected.
Yeah.
So we can say all the population. So today we talk about epidemiologist role. First of all, we talked about the great experiment that says that the epidemiologist is really a hardworking one who's going to write a 200 pages report about something he didn't even touch. And classification of the disease, who can remind me in it? Sporadic, epidemic, and hyperepidemic. Epidemic is divided into common source, which are from common source, and propagated, and mixed. Right. Incidence and prevalence, we talked about them. Sources of data, which are reports. Cohort and case control, we're going to leave it for Dr. Dima. Thanks God. Susceptibility and immunity, and we talked about transmission of viruses. So, which photo after this lecture do you think that express the epidemiology? Or epidemiologist?
The right on the photo.
The first one?
No, the
first
on the left.
right bottom.
Okay. So that's what people really think. Maybe we're gonna change our mind when we be epidemiologists. No one knows. So epidemiology is actually a power. It's a power. You can control diseases through epidemiology, through analyzing and collecting data. You can manage disease, you can prevent disease, you can actually help solve